Dear students, in this section we are going to learn the concept of conservative field and non-conservative field. In this section we will discuss how to identify given field is conservative or non-conservative. Suppose in certain region the potential is changing with the x, y and z coordinate, right? That means potential function is a function of x coordinate, y coordinate or z coordinate. We define electric field as negative gradient of the potential function. That means E vector equal to negative gradient of V. This is the E vector, electric field vector. This is the gradient operator. This is the potential function. And if we expand this gradient operator, we write this equal to minus del V by del x I cap, del V by del y j cap, del V by del z k cap. Okay, these are the partial derivative term. Suppose potential function is a function of x, y, z, and if we want to have the partial derivative of the potential function with respect to x, in that case we will consider x is only variable and y and z as a constant term. Similarly, if we want to have the partial derivative of the potential function with respect to y, we will consider x and z as constant and y is only variable, and similar treatment is done for the z coordinate also. Okay, suppose we have certain field in a region which is given by f vector equal to fx I cap, fy j cap, fz k cap, right? That means the field in certain region have the component fx, fy and fz. If this field is conservative, that means the curl of this field should be 0. Now this curl term is new term. Let us learn how to find the curl of certain field. We define curl of field as, suppose we write curl of f vector. This is equal to gradient operator cross product f, and it is written in the determinant form. In the first row we write I cap, j cap, k cap. In the second row we write del operator del by del x, del by del y, del by del z. In the third row we write fx, fy and fz, right? Let us learn the application of this concept through some selected illustration. So let us move to illustration number 1. It is given an electric field at certain point is given by f vector equal to 2xy I cap plus x square 2yz j cap plus y square k cap. We need to check this field is conservative or non-conservative. Okay, as we discussed, if certain field is conservative, then curl of field should be 0, and we know the curl of certain field can be written in the determinant form. So what we will do, we will write this function, right? This is the field function and we need to find the curl of this function. So let us find the curl of this function like this. Okay, you can observe here in the first row we have written I cap, j cap, k cap. In the second row we have written del operator, del by del x, del by del y, del by del z, and the third row we have written x component, y component and z component. From this function we can find the x component as 2xy, y component is x square plus 2yz and z component is y square. So let us write the x, y and z component here. Okay, now it is simple determinant. Now we'll open this determinant. For opening this determinant, what we will do, we select this first row and first column, right? We will write I cap first. So let us write I cap, right? Then we will do the cross multiplication. So in the bracket we will write del by del z, del by del y, and this is y square, derivative of this, and cross product of this and negative sign in between. We will write del by del z, and here this is x square plus 2yz. Okay, bracket close. Now we will select this row again, but this column, but we substitute negative sign, and now do the cross product again. So this is j cap, okay, and in bracket we will write del by del x y square, and again cross product, and in between negative sign del by del z, and this is 2xy. Okay, now we will select the third one. So select the black ink here. So we'll take this, we write k cap, now k cap, and here again cross product. In cross product we will select this one. So we will write del by del x, and this is x square plus 2yz, right, cross product of these two, and again negative sign in between, then cross product of this. So we'll write here del by del y, and in bracket term we will have this 2xy. Okay, now let us write in the proper way like this. The first term, this is the second term, this is the third term. Now we can observe the partial derivative of y square with respect to y, that should be equal to 2y, and partial derivative of this function with respect to z, this will be 0, and here this will be 2y only, and partial derivative of y square with respect to x will be 0, because this will be constant for partial derivative of x, and here partial derivative will be 0 because there is no z term, and here we can observe partial derivative will be equal to 2x, and partial derivative of this will be 0, and similarly partial derivative of this term should be equal to 2x. So let us write this one, first one, and for the second one we can write like this, and for the third one we can write like this. Okay, and we can observe here this after solving will be 0. That means this given function is the conservative one. Now let us take second illustration. In this illustration we have the component of electric field at certain point as Ex equal to minus ky, Ey equal to kx, and Ez equal to 0. And here again we need to check whether field is conservative or not. Okay, let us write the x, y and z component. X, y and z component. If this field is conservative, that means the curl of this field should be 0. Now let us find the curl of this field. We will write a gradient cross product f equal to this determinant term. In determinant, first row I cap, j cap, k cap. Again in second row we have written the del by del x, del by del y, del by del z, and the third row we have written the x component, y component and z component. Now let us expand the determinant, first row and first column, and cross product of this. So this will be first one. Now negative sign here. We will select this first row and second column and cross product. Cross product, this will be 0. Derivative of this will again going to be 0, like this. Okay. Now we will select this row and this column, and derivative of cross product of this, right, again negative sign, and cross product of this one, like this. Now we can simplify. This will be 0 and 0. This is 0. This is again 0, right? So 0 and 0, and partial derivative of this is equal to minus k. Minus k and minus will positive. So this is k cap, and it is not equal to 0. Now we can say curl of field is not equal to 0. That means this field should be non-conservative.